Today I'm going to show how to use SdrGlut to capture GPS data. The basic setup is I've got SdrGlut running and I've got an SDR Play RSP2, and the SDR Play RSP2 is plugged into an active antenna. And so let's get started here. We start up the program with the SDR Play, and we set the frequency to 1575.42E6. That's the frequency of the GPS, and we set the sample rate to 6 megabytes a second. I found that 6 megabytes a second seems to work best here. And so we start up SDR Play, and it turns out we've got to adjust the gain on SDR Play, and so I'll turn the gain all the way up and then back it off a little. Somehow that seems to be the place where it likes to. I'm backing off to a gain of 5. And now let's turn on the active antenna by turning on the voltage to the active antenna. Let's see if the signal level goes up. Yep, it goes up. Only goes up 5 dB. They claim it's a 28 dB device, but it's not. It's only 5 dB, but turns out that's just barely enough gain. And so now we go to record the IQ data, and so I set the record on the IQ data. I come here, save, and so now it's ready to save the IQ data, and I can start recording. And here you can see on the desktop the file appeared, and in the background it shows that it's writing to the file. And so now it's saving a 6 megabyte swath around the center frequency of the GPS data. And here you can see a peak showing up. Sometimes those peaks come from the hard drive. The hard drive is generating noise at GPS frequencies, but sometimes it seems to hurt and sometimes it doesn't. And so now I'll stop it. So that stops it, and quit. Yes. And so now I'll pick up a file that I recorded a little while ago instead of that one. And what you need is the gnss-sdr program in order to analyze the data. And I have another video that shows how to install that. And here what you need to do is you run GNS data with a configuration file, and this configuration file is called my first gnss-sdr receiver.config, and it's a slightly modified version of what they have on the website. And basically the only changes made to the file it points to my file here, and I changed the sampling frequency to 6 megabytes, and I changed the sampling frequency here in the downsampler to 6 megabytes a second. And so now we'll go ahead and run it on this data set, and it goes through and looks for satellites, and when it gets enough satellites it'll start spewing out the position information. And so it can't do that. It just There, now it's giving the position information. Weird, the first time it didn't do it. But there it spewed out the position information. So their algorithm is not deterministic. That's pretty bad. And anyway, so what you get is you get the file. These files here have the GPS points that it determined, and it also has this KML file that you can run into Google Earth. And so I'll start up Google Earth, and this is zooming in on where I did this, which was down the street by the park. And you can see right here are the points that it found. And turns out the position is off by about 20 feet. I don't know why it's so poor. But anyway, that's how you can use SdrGlut to capture the GPS data, and you can use the GNSS to process it and show you the information. If the GNS had the bias in their program so that you could turn on the active antenna, you could do it in real time, but at this point in time they don't.